As we have seen how to create a virtual machine with custom configuration and then set up post installation script in that virtual machine, now let us actually go ahead and explore how to create multiple virtual machines. So in this case, we just have to take the Vagrant file which we have developed earlier and customize it in such a way that we iterate as many times as we want and create as many virtual machines as we want. For this demo, I am connecting to the remote server. And earlier we have tested our creating our program which creates custom VM and set up post installation scripts under this directory called Centos 7. You can see a Vagrant file here and also bootstrap.sh script. So what I am doing is I am creating a new directory, servers, because I want to create multiple servers in it, and then I am copying both bootstrap.sh as well as Vagrant file into that servers, and now I am getting into the servers. And if you actually open the Vagrant file, you can see that it is creating the virtual machine with 2 GB RAM, 2 CPUs, 2 hard drives, one with 20 GB and other with 40 GB. It is assigning a static IP, and this is the host name, and the operating system is based on the box which we have specified here. And also it is actually setting up post installation scripts by executing bootstrap.sh. Now to create multiple virtual machines as part of this vagrant.configure, I have to iterate as many times as I want, and I have to define each virtual machine with the settings that are dynamically generated, and then we have to create the virtual machines. So first let us identify all those things which we need to pass dynamically. I want to avoid hard coding as part of this main logic, and wherever hard coding is involved, we will try to come up with a variable, and we will assign value into that variable, and we will be using those variables here. Okay, so first I want to define instances, and let's say I want to create 7 instances, so I am assigning value 7 to it. As of now this script is not using it. Now we can actually say box equal to CentOS /7, because that is the box which we want to use. And then when it comes to name, we cannot have same name for all the boxes. We need to have a unique name for each virtual machine with the CentOS on top of it. And hence I want to divide this name into 3 parts. One is prefix, which is common to everything. Another one is suffix, which is common to everything. And then in the middle I want to keep a placeholder. Okay, so for example in this case, let's say I want to read the box. As it is Ruby, the way you can read box in this case is by writing code like this, hash, and in curly braces you have to define the variable name, which is box in this case. So at runtime this will be replaced with this value. Okay, and also when it comes to name, I want to have 3 parts. One is name prefix. I have to define a variable with that name, and then I will be kind of a counter, and then name suffix. Okay, so now let us define those variables. And also I want to use a different provider, and also we need to dynamically generate these IP addresses. So I will define a variable called IP prefix, and then I want to append I to it. So I am just trying to increment each time and trying to generate this static IP dynamically in each iteration. Okay, so you will understand once I actually define values for all these variables. And then provider, I want to switch between the provider based on the environment where I am running. I might want to use VirtualBox in my Mac and then Libert on the remote server, and hence this also I want to keep a placeholder by saying provider. Okay, and then memory, which is nothing but this one. So we will create a variable by name memory, and then CPU. Okay, CPUs. And then when it comes to storage also, I want to create multiple devices, and we can actually do it in a loop. Okay, so we will actually come back to this and change it at a later point in time. And then we can actually define the script also, script path also, by using variable called path. Now let us define the variables which are being used as part of the program. I want to add provider. In this case I want to use libvirt, and then name prefix, which is nothing but server 0, and then name suffix, which is nothing but itversity.com, .itversity.com, and then IP prefix, which is nothing but 192.168.100.20. So as I am creating 7 virtual machines, it will create virtual machines with 200, 201, 202, 203, so on up to 206 with the common subnet. Okay. If you want to create more than 10 virtual machines, then you have to play how you can actually increment. You have to come up with a logic to capture this, increment, and then append. Okay. But for now we will be creating under 10, and hence this is good enough. And then the storage devices, I want to create 2 of them, and I want to assign the same size for each of the devices on each machine, which is nothing but 60 GB. Memory I want to define as 2 GB, and then CPUs I want to define as 2, and path of our bootstrap script is nothing but bootstrap.sh, because we have the script in the current working directory itself, so we don't need to worry too much about it. Now as we have created all these variables, instead of using config here, I have to iterate in a loop and then define a new box, and I have to take it from there. So as I am creating 7 virtual machines, first I have to read instances, which is nothing but 7. So we are saying 7 times iterate, and in each iteration we are actually reading the value as I. So in the first iteration it will be 0, in the second iteration it will be 1, in the third iteration it will be 2, so on and so forth. Okay, and then as part of this, first we want to create a ID for our node. So the way you can create ID is take the name prefix. So if you observe, when we try to create virtual machines, and when we actually run Vagrant status, it actually shows default as the name of the virtual machine, and then it will show status. That is actually ID. So in this case we are trying to generate that ID, and I want to dynamically create a different name for each machine, and in this case I will be using prefix. Okay, name prefix, and then I. So this is my ID. Using this ID, I have to define the name of the virtual machine. So how can we do that? So what you are supposed to do is you can use config, which is nothing but this one, .vm.define. Okay, so we are trying to define a new virtual machine, using node ID, and in this VM we want to set multiple settings, and hence I want to develop the logic, and I want to give it as node here. So I am trying to configure multiple nodes. Now once we say config.vm.define, all these settings which we are using as config now can be set using node. So we are trying to set up a new node with different settings. Okay, in each iteration the node will be based on the node ID which is dynamically generated. So I have to replace this with a node. Replace this with node. Okay, now again to set these settings we have to again loop through based upon the provider. Okay, and in this case I am just formatting the code. In this case I am defining this as VM. So for each VM which we are trying to create, we want to set the memory to be 2 GB and CPUs to 2, and then storage again we have to iterate. We will come to that in a moment. First let me close this loop. Okay, and then this is for instances.times. We have to close it for config.vm.define also. Okay, and then this is for the main one, and this one also I have to paste it here. Okay, and okay, this one all should be in this, and I have to replace this with node. And now I have to loop once more, and let me change this to VM because here we defined it as VM, so I am changing it to VM. And now I have to get storage devices, which is nothing but 2 in our as part of our variable. You can see here we have assigned 2 here. Okay, so I have to iterate as many times the storage devices is defined dot times, and then you can specify do here, and I am creating a new variable called j. Okay, and here I am closing this loop as well, and then size, we have size variable defined by using disk size. So I just have to say hash disk size. Okay, and then I have to close this. This is how you can actually write the program. So what we are trying to do, we are reading all the variables which are defined as part of the program. So first we are trying to get the default configuration, and then we are actually looping through as many times as instances is defined. So in this case 7. We are defining the ID for our each of the nodes. So in each iteration we will get this prefix and then the incremental I, and then ID will be like server 00, server 01, server 02, etc. And for each of those nodes such as server 00, server 01, so on and so forth, we are defining the properties of the virtual machine. So the VM box is of Centos 7. Host name will be prefix, which is nothing but name prefix and incremental and suffix. As we have created variable node ID here, we can also replace this with hash node ID. We don't need to concatenate id again to the name prefix before concatenating name suffix. Okay, you can do either way. And then we are actually giving static IP, a unique IP for each and every virtual machine using the IP prefix. And then for each virtual machine, based upon the provider which we have defined, we are trying to create set the configuration such as memory, CPU, and storage based on the variables. And then finally we want to we want to run the post installation script and install the packages which are defined after creating the user. Okay, as we are done with the development, we can save it, and you just have to run sudo vagrant up provider equal to libvirt, and you can see that it is actually creating all 7 virtual machines in parallel. And in the same amount of time which it took earlier to create one virtual machine, you will almost get 7 virtual machines. Probably there might be some little additional overhead depending upon the capacity of your machine, but it is pretty fast. Within 2 minutes, you will see all the 7 virtual machines. Even the packages will be installed in parallel on all of them as part of post installation, and all the 7 virtual machines will be ready in 2 minutes. So you can see that the installation of software is started. We try to install wget, telnet as well as Java as part of post installation script. Based upon the network speed, it might slow down a bit, but if you see, it is actually taking care on all the virtual machines in parallel. Okay, so we just started the command sudo vagrant up around a minute back. Already all the virtual machines are available to you, and within another 30 seconds to 1 minute, even the post installation scripts will be executed in parallel. If you have to do this manually using VirtualBox, creating all the 7 virtual machines, configuring the network between them, and then installing the softwares will easily take an hour. Or even more than that, it might even take more than 1 hour, and sometimes as part of manual process while setting up networking, you might run into some issues, and hence it might take a lot more time for first few iterations. With Vagrant, once you understand the concepts, and if you are capable of customizing the script quickly, you should be able to create n number of virtual machines in very less number of time. As it is running, meanwhile, let us try to set up on my PC or Mac where I have VirtualBox and Vagrant. Okay, I am already in that directory. Let me copy these 2 files. I exited from here, and I am creating a new directory called servers, and I am getting into that servers directory. And first I want to create the bootstrap.sh with this content. Okay, saved it, and then I want to copy the script to Vagrant file. But in this case, we have VirtualBox, not libvirt, and hence provider has to be VirtualBox. And with respect to VirtualBox, setting up the disks will not work the same way as libvirt, and hence we have to comment these 3 lines. And then save it, and then you can run Vagrant up. Oh, 1 minute, I don't want to launch all 7 virtual machines in this because I don't have so much capacity to run 7 virtual machines of 2 GB size and 2 CPUs in each. Okay, and hence I am replacing with 3 here. Okay, so if you are running on your local machine, make sure you define number of virtual machines based upon the capacity of your machine. and then I can run Vagrant up. One caveat with respect to VirtualBox is, unlike with KVM where the virtual machines are created in parallel, here they will be created serially. So it will take a bit more time than the time it took to create virtual machines on the Linux server with KVM. But it saves a lot of time in setting up network and all those things. Okay, so depending upon the number of machines you are trying to create using VirtualBox, the amount of time can increase linearly because all the machines will be created one after the other. Whereas on libvirt, they are created in parallel, and within a minute or two, you will get all 7 virtual machines, and you can actually run sudo vagrant status, and you can see 7 virtual machines here. Server 00, server 01, server 02, so on and so forth up to 06, and this is nothing but the ID. And you can actually say connect to any of these machines using vagrant ssh command, but you have to specify the virtual machine ID such as server 00, otherwise it doesn't know which virtual machine you should connect to. And now you are in that virtual machine, you can see the host name. It is server 00.itvarsity.com because we have used the name ID with the suffix, and that's what is assigned as name. You can also run IP ADDR to get IP addresses. You can see a static IP along with a dynamic IP for this machine. You can also see the user admin, and he belongs to the wheel. Also, if you look at sudoers, you can see all the users which are part of group wheel can now sudo without prompting for the password. Also, we have enabled a password login. We can validate it by saying admin at. In this case, if you try to use the names such as server 00.itvarsity.com, server 01.itvarsity.com, it might not work. You have to give the static IP or dynamic IP. So dynamic IP is this one. You can use this and enter the password, and you can log in as admin directly, or you can also say 100.200 yes and enter the password. Okay, so either you can use static IP or dynamic IP. The reason why we try to create static IPs always is dynamic IPs change every time you reboot the machine. Depending upon the availability of IPs, it will figure out which IP it should use, and it will change. Using static IP, we can configure all our applications without worrying about changing the IPs. Okay, that's why we try to set up static IPs using private network as part of creating virtual machines. Now, if you go back to my local PC, okay, it is still installing because internet speed is a bit slow from wherever I am recording this video, and hence it took a bit of time. Otherwise, it will be done very quickly. On the remote server, it is fast because it is using the internet of that data center, not the public internet. Okay, now installation is done even on those 3 virtual machines which are created on my PC. You can actually say Vagrant status here, and you will be seeing the 3 virtual machines. Okay, so this is how you can actually create virtual machines dynamically by customizing the Vagrant file. That being said, if you actually look at the approach, first I have developed the script on my remote machine, and then I copied the script onto this machine, and I have to make changes to the script. This is not a good way of dealing with the scripts to run in multiple environments. We have to externalize the values of this. So as part of the next topic, we will see how we can externalize these values so that we don't have to touch the Vagrant file. So we'll create a YML file and dynamically pass these values, and also we'll develop the logic in such a way that depending upon the provider that is provided here, it will automatically decide whether to add storage devices or not. Instead of commenting out like this, we'll be using the same program to create additional drives if we are using libvirt. If we are using VirtualBox, it will not create these additional drives, and we will see that as part of the next topic.